What's up guys, welcome back to the next video in learning C++. My name is QTS Dani and you guys watching my channel Wood. So in this video we're gonna discuss copy constructor. What is copy constructor? We have shown you guys the overload constructor in the previous video. Just if you guys go back and watch the previous video, and we have here, because we saved a call, we saved our file here. So static Corio was our class name, and we have here our static. So we have discussed the static in a class and static in a function. So if you come here, that's a static variable inside the function. Alright, so and also in the previous videos we have discussed overloaded functions and overloaded constructor. So this is our loaded constructor. That's how you guys overload, because that's our first constructor, default ones, and that's the second one. Alright, so copy constructor is exactly similar like that. That's one of the most important forms of overload constructor. That is the copy constructor. So we begin, and we're gonna see that's how the copy constructor gonna solve our problem. Alright, so we're gonna close this one, and I already explained to you guys, so you guys got the idea of the overloaded constructor. So now we're gonna come here in the past. That was our previous videos, and we said that objects can be passed to a function using call by value. How we're going to pass the objects to a function? And if you look in here, we have an object y, and we have access the methods, whatever the methods here, set number, and we put it on 50 because we're passing by value. So if you look in here, we are passing these objects to this function, and this function's name is Corio. We are passing this y, which is the object. So what happens inside this object? So when the object is passed to a function, like here, if you look in here, when this y, which is the object, we pass it to a function, to this guy here, which is this function's name is Corio, it's like a bitwise. What happens that the exact copy of this objects is passed to a function. So what we mean by exact copy or bitwise? So what happens if these objects contain a pointer to some allocated memory somewhere? So if the objects contain a pointer to, say for example, somewhere in allocated memory, then the copy will point the same memory as does the original object. If the copy makes changes to content of the memory, it will be changed for the original object too. Say for example, when the object terminates, the copy will be destroyed, thus causing the destructor to be called. This may have undesired effect on the original object. So whatever happens to one copy of the object is going to happen to original copy. If the guys destroy the copy of these objects, then it's going to have the original objects going to have a undesired effect on the original object. So if anything happens to the copy, it's going to happen to the original object, which is this guy here. So that's why this have we don't want some cases, because these objects connected to each other and they are copies of each other. So I'm here, I've got an object here, and I've got an object in my here, which through these objects I'm accessing all these functions, and here I'm passing this object here. So I'm making a copy, exact same copy of this one to this function. So what happens to the copy? Whatever happens to the copy is going to happen to the original object. So imagine you guys got a very long program and you guys passing this object to a function. So in somewhere you guys gonna destroy the copy. Say for example, you guys destroying the copy, then what's going to happen to the original object, which somewhere sitting inside your program, and it's going to have a lot of bugs, and your program is going to crash because you guys copied. Because this whenever you guys pass here, you guys gonna pass the both copies here. So you got this copy here, then through the bitwise here, we are passing this object to this function, but in reality we are making exact same copy to these functions. So anything happens to this the copy ones somewhere in the memory or somewhere, whatever you guys doing, is gonna affect this one as well. So, and I'm gonna say again, so if it's the object contain a pointer, so somewhere in the memory, then the copy will point to the exact same memory as does the original object. So if the copy makes a change to the contents of the memory, it will be changed on the original object. So when the function terminates, the copy will be destroyed. So if we terminate this function, the copy is going to be destroyed. Then what happens then, as a consequence, the destruct will be called, and once the destruct will be called, it means that's it's going to have undesired effect on this object. Okay, to solve this, we're gonna come here and we're gonna discuss the copy constructor. So how we're gonna make to bypass this to say solve the problem. A copy constructor, in the simple words, a copy constructor is a member function that initializes an object using another object of the same class. A copy constructor has the following general functions. Say for example, if you have here, I'm going to put it here, we put a class name, say what was our class name, so we're going to come here, our class name was pass, for example. Our we put a new class name, say our class name is Corayo. Say what happens, and we're gonna put a constant, which we're gonna put a const, and we put a class name. So we put a class name and we're gonna reference it to old object, so whatever the old obj, which is the old objects. So that's the copy constructor. And a similar situation gonna happen when the object is going to return to a function. Then what happens, the compiler is going to generate a temporary object that holds a copy of the value returned by the function, and that is the out of our control. You guys don't have a control of the compiler. This temporary object goes out of the scope once the value is returned to the calling routine, causing the temporary object's destructor to be called. And as a consequence, your program is going to have a lot of bugs, and there are going to be undesirable consequences on your program. So to control this, we need to have some sort of control of precisely what happens when a copy of the object is made, that you can avoid all these crashes and all these bugs. So the way to do is that to bypass this or to control this is that we have to make a copy constructor. And to understand this, the C++ defined two distinct types of situation in which the value of one object is given to another. The first situation is assignment, when we assign, and I show you guys the assignment. The second situation, initialization, when we initialize the object, and it happens with three ways: when the object explicitly initializes another one, such as in a declaration, and when a copy of the object is passed to parameter of the function, as we said that here, and the copy of these objects we pass as a parameter to another function. You can look in here. And the last one, when a temporary object is generated as a return value, and we have shown in a lot of programs the return value. So the copy constructor, keep in mind, only applies to the initialization. So copy constructor is only applies to initialization, not assignment. So when we create a copy constructor, it only applies to initialization, and it's not an assignment. So a copy, simple words, a copy constructor is called when the one object is initializes another one. So if you have one object here, which is obj, and when it initializes another object of the same class, then what happened as a consequence, the copy constructor will be called. Okay, so as I said, that this happens only to initialization. It's not happening on the assignment. So we're gonna go through this before we continue with our copy constructor. And as I shown you guys here, see here we are passing the object, and our object is y to a function. So when object is passed to a function and that's as an argument, a copy of the object is made. So now we have a copy of the object as we said before. And if a copy constructor exists, the copy constructor is called when the is called to make the copy. Here's now we're gonna make the same situation, same scenario, but with the copy constructor. But copy constructors, we got a full control. So it's not like if you pass this objects to this function, then whatever happens, if this function dies, then destructors will be called and it's gonna affect the original object. Okay, so then we don't want that, and to solve this we need to create a copy constructor. Now we're gonna come here and we put a class, for example, and I'm gonna put a comment because I'm not going to use that class, so I'm going to put my class here underneath here. So I've got a class, say I'm going to put a copy const, for example. So I know that my class is about copy constructor. Now my class is set, and I'm going to have int. Now I'm going to have a pointer, say PTR, for example. That's my pointer, and I want to make sure that I'm not using this pointer somewhere else. So I have a int and I have a PTR. Okay, so PTR func is inbuilt, but I'm using PTR, so that's fine. Now I have a public. I'm gonna put my public section, and my public sections I'm gonna put my constructor and my destructors and my copy constructor. Keep in mind, I need a constructor, I need a copy constructor, for example, and I need a destructor because you guys need to destructor as well. And you guys should already know the destructors. So now I'm gonna put my constructor, and my class gonna be copy const. So I'm gonna bring my class here. So I'm gonna call the copy const, and that's my first constructor. Copy const. So that's my first constructor, and that's a default constructor. This is default constructor, and my default constructor have I'm gonna have int inside, and I've got a parameter int I, for example, or int a, for example. You guys can put whatever you guys like, and I'm gonna have cout. And I'm gonna have this is coming from default, our normal, our we're gonna put a default constructor. So this is coming from the default constructor. That's what we're gonna pass the message, and we're gonna say that we are allocating some sort of memory. So you're gonna put allocating. Okay, so that's we're gonna put our endl here, and what happens here is that we're gonna put a pointer, and we put a new int. And here we have our pointer here, and we are gonna assign this I. Alright, so now we're gonna put our destructor here. So we're gonna put our destructor. So I'm gonna put a copy const, and I'm gonna put my destructor here. So it's gonna be copy const as well. And I'm gonna put a cout, and I'm gonna put this is coming from destructor and we calling destroying. So this is coming from a destructor, and we're gonna say that's destroying. Alright, so now we're gonna delete and the pointer. We're gonna delete that pointer because we don't want that anymore. Okay, so now we're gonna come and do our copy construct, and the copy constructor is gonna be copy const, and we put a copy const. So I have a copy const, and it's gonna be, as we said here, const your class name and the old objects. So we're gonna put a, so we put a const, copy const, that's our class name. So here we put our class name, and we put a reference to the object. So here we put a object, or you guys can put a obj like that, so you guys can put an object, so you guys know that. Okay, so now we have the normal default constructor, we have our destructor, and here we have our copy constructor, copy const, and here we have our destructor. Okay, so now we kind of come here, and we're going to say our p, our pointer, and here we put a pointer. P and pointer is going to be new int, and here we're going to put a pointer, and we put a new, same as top, we put a new int. Now we're going to say pointer, which is the ptr, and we're going to copy, we're going to point to this object, obj object dot ptr. Okay, so we're gonna put a c out, and we're gonna be copy constructor is, this is coming from copy constructor. So now we have we're gonna put an end l, and we're gonna say that this is coming from the copy constructor, and we're gonna put our constructor, and our constructor is going to be int I on top. We need to declare it, so I'm gonna put here the first one, and I'm gonna put my destructor as well. So I'm gonna come here, I'm gonna put my destructor, and the last ones, and I'm gonna come here, and I'm gonna put my copy constructor here. So I have a constructor on top. So I have a constructor, the normal one. I have a copy constructor, and I'm put a const, the class name, and I'm gonna put a reference to object, and I have a copy const, and I'm gonna destroy this constructor. I have a destructor there. So now I'm gonna create another function, and I'm gonna put a int, and this int is gonna be, say for example, I'm getting the number, I'm getting the get number, so I'm getting the number here, and this function is gonna return my pointer, return, and the pointer ptr. So I'm gonna put this one on top, int get number, and I have to go there on the declaration, and I put my int number, get number. So I'm coming down, and then the last ones is I'm gonna create another one. So now we need a function to take a object parameter, take object parameter. So to take object parameter, we're gonna put a void show because we're gonna show the object parameter, and that's gonna be copy const, which is gonna be my class. That's a copy const, and we're gonna put some sort of xyz, or you guys can put a say y is, say we put a z. So this z is we're gonna put a c out, and we're gonna put a z, and we're gonna put a get number, or you can put this one like that. So now we have a function to show our whatever value, because we're gonna take the object parameter, and that's this get number. We're gonna get the number here because we are returning this pointer, and here we gonna put some sort of constructor, and we put a this z, because that through this one we're gonna access this get number, and we're gonna see our copy constructor, because as you guys know, here we're gonna do exactly the same here. So now you guys in here we have an object. We're gonna create an object, and we're gonna pass some sort of number there. Then we're gonna pass this one, and we're gonna see and then we're gonna see our number, and then we're gonna call the destructor. Okay, so now we're gonna come here, and we're gonna say our constructor is gonna be copy const. We're gonna call our constructor, and our constructor is gonna be copy const, and for example you guys can put xyz, or you guys can put, say for example, x. I'm just gonna see if I have declared x somewhere around here. No, I've got a pointer, and int I haven't got x. That's fine. So what I'm gonna do now, and I'm gonna pass some sort of value inside the x, for example, and say for example I'm gonna pass, say 20, or you guys can pass any other number. You guys can put this number. So now this object's got a 20. Now we're gonna pass it to the show here, because our show is going to take one parameter, and and that parameter is going to be z, and through that number we're going to return our pointer. So now we're going to put a show, and we're going to pass this x inside, and we're going to pass this z inside, and we're going to return. Alright, so before we run, we're going to check our program, and we're going to build our program. So I'm getting a problem here. I'm going to remove it from here, and I'm going to put it inside the public. I'm going to run it again. Okay, so I'm making a mistake here, because that z is here. I should pass this one. I should pass this x, not z. Okay, so I'm gonna run again. All good. And I'm gonna, so this is coming from default constructor and allocating. This is coming from the copy constructor, and that's coming from the copy constructor. You guys gonna look, and now here we are gonna put a 20, because we have passed the 20, and now coming from the destructor, which is gonna be this one, destroying this one and destroying the second one. Now you guys gonna see that how we have passed to function here. So now it's exactly like that. Same situation here. So we had a function here, and we have allocated some sort of number. We have passed it to the function, but the only difference is now anything happens because this here whatever we pass is going to be bitwise. What do we mean by bitwise is because what now the exact copy of this object is created inside this function, and whatever happens to the copy, and this gonna, so if this function dies, then the destructor will be called, and they have undesirable consequences on this object. But here the situation is totally different because here we have a copy constructor, and say so we have that's our first constructor, that's a destructor, and that's our copy constructor, and we are copying the object here. So here we have a pointer, and that's going to be the type int, and when we're getting the number, because we are pointing to that pointer ptr. So that's our default constructor, that's our destructor. You guys going to see, and you guys needs to destructor to destroy the object. And now here the copy const, and that's exactly the you guys needs to put a const, and then you guys needs to put a class name, and you guys needs to put a reference to the object, and through that one you guys needs to put a new int, and that this pointer is that object dot ptr gonna point gonna have this pointer, we're gonna assign to this one, and we're gonna display that one. And here now we have to need some sort of function to show, and here we have our object, and we have a 20 inside, and now we are here we gonna have to show. Alright, so but the problem, I put this z instead of this x. I should have put the object, not this one. Alright, so I'm gonna run again, and we're gonna display that again. So the coming from the default constructor is allocating, and it's coming the copy constructor, and then now we're going to see the number 20 because we have passed this one to this function. And after that, when we pass, now this coming from destructor destroying, and they're destroying everything. Our destructor will be called, and the destructor is destroying everything. So how this destructor is going to come, because we didn't put anything here, because we have put this copy constructor, and that's our initializer. And as I said to you guys, this happens only on initialization. It's not happening on the assignment, because copy const is our constructor, and initializes this x, because x is with the 20. It happens on the initialization. As I said to you guys here, copy constructor is only applied to initialization, not assignment. Okay, so it only initializes with this 20, and when we pass this one 20, it's going to x, and this our object's name is x, and we're going to go here because we are calling this function here, this function we are calling this one. So this got our object, and that's our class name, that's got an object. So and here, so this is our constructor, and that's our object. So here through this one we're gonna go on the get number, so we're gonna see the get number here. The get number is gonna be inside our public section, and inside the public section we are returning this pointer, which is this guy here. So and now here, because we have a default normal constructor, default constructor, and we have a copy constructor, and we have a destructor here. So and all of them will be called one by one. And you guys looking here, that's our default constructor, that's our destructor, and that's our copy constructor. And the copy constructor very useful. Now anything happens to this copy of the objects, because now whatever we have objects, and initializes 20, and we've seen the 20 because we are locating that one. And now anything happens to the objects, is not going to affect the original objects. Even if this function dies, it's not going to happen to this one. It's not going to create any bugs. So now we have solved the problem with the copy constructor. So the copy constructor solves the problems from your programs crashing or programs getting bugs. Alright guys, that's it for this video. If you have any question or comment, leave in comment box. Otherwise, I'll see you guys in the next video, and bye.